Something huge just barreled into our solar system. It's moving incredibly fast, and it's not from around here. It came from the vast emptiness between the stars. And, scientists are scrambling, but some of them are asking a question that sounds like it's straight out of a sci-fi movie.
So yeah, let's get right into it. That's the huge question, right? Because this thing, our third confirmed visitor from interstellar space, is at the center of a massive debate. Is it just another space rock, or could it be something else entirely?
So picture this. It's July 1st, 2025. An observatory down in Chile picks up this faint little dot. But this dot is moving, and it's moving fast, hurtling right towards us from the super bright center of our galaxy. They give it a name, 3I/Atlas.
Now, when we say interstellar visitor, we mean it's not trapped by our sun's gravity like all the planets are. This thing is a true tourist, just passing through from another star system. You might remember our first one, Oumuamua, back in 2017. That one it was just plain weird. Then came Borisov in 2019, which looked a lot more like a regular old comet. But this new one, this one is in a whole different league.
And look, you don't have to be an astrophysicist to see why this thing is making waves. Just check out the stats. 3I/Atlas is clocking in at a mind-boggling 58 kilometers per second. That is more than double the speed of Oumuamua. And its size? We're talking an estimated 10 to 20 kilometers wide. That's not just bigger than the others, it's a completely different scale. It's an absolute monster. So when you have something this big and this fast, well, it gets people thinking. And that's exactly what led some scientists, most famously Harvard professor Avi Loeb, to put forward a pretty wild idea. He's suggesting that maybe, just maybe, 3I/Atlas isn't natural at all. That it could be, an artifact, something designed by an intelligence.
Okay, so Loeb's team lays out this case based on a whole bunch of things that, when you put them all together, start to look, a little too convenient. First off, its size. An object this huge showing up is supposed to be like a once-in-10,000-year event, not something we see every few years. Then there's its orbit. It's suspiciously flat, almost perfectly lined up with the path of our own planets. And get this, its trajectory is perfectly set up to get a close look at some key planets. But the weirdest part? Its closest swing by the sun is timed to happen exactly when it's hidden from our view on the other side of the sun.
Let's just pause on those flybys for a moment, because this is wild. What are the chances that a random rock from another star would just happen to line up its path to get a close pass of Mars, Venus, and Jupiter all in one go? Well, according to the calculations, the probability is about 1 in 20,000. That's 0.05%. I mean, the odds are just astronomically small. So let's just walk through this supposed flight plan, right? First, it comes in from a direction where the bright galactic center makes it super hard for us to spot it early. Total stealth approach. Then it swoops in for a close-up of Mars and Venus. Next, it conveniently ducks behind the sun, where if it were a probe, it could fire its engines or make a course correction, and we'd be completely blind to it. And then it pops out on the other side on a perfect trajectory for a flyby of Jupiter before it shoots out of our solar system for good. You can start to see why some folks are saying this looks less like a coincidence and more like a carefully planned mission. Okay, but before we all get our tinfoil hats on, there is, of course, another side to this story, a much simpler one. For the majority of astronomers, the explanation is powerful because it's simple. It's not a spaceship. It's just a comet. A really, really big and unusual one, but a comet nonetheless. So, quick science refresher. What's a comet? Think of it as a giant, dirty snowball whizzing through space. As it gets closer to the sun, it starts to heat up, and the ice on its surface turns straight into gas. That's a process called sublimation. That's what creates that classic fuzzy halo, the coma, and sometimes that long, beautiful tail. And honestly, the evidence that 3I/Atlas is a comet is really, really strong. Our telescopes have actually seen a fuzzy coma around it. They've spotted a tail. Its color? A reddish hue, which is pretty much textbook for a comet. We've even clocked its rotation. It spins about once every 29 hours. And maybe the biggest tell of all, it's getting brighter and more active the closer it gets to the sun. That is classic comet behavior. So there you have it. Two completely different stories. In one corner, you've got a chain of coincidences and statistical long shots that just seems too wild to be random. And in the other corner, you have a bunch of physical observations that are practically screaming, "I'm a comet." So how do you even begin to decide which one is right? let's just lay it all out, side by side. The whole alien probe idea? It's built on things being highly improbable. The weird trajectory, the convenient timing, its massive size. But the comet theory? That's built on things we can actually see. Direct, physical observations of its coma, its tail, its color. In a way, it's a fascinating scientific showdown. Mind-bending probability versus cold, hard physical proof. So you might be wondering, what does Professor Loeb himself think? After all this, is he 100% convinced it's alien tech? Well, in an interview, someone asked him to basically put a number on it, to quantify his certainty. And his answer was really measured. He didn't go all in. He just said, I put it at 4 right now. A 4 out of 10. Now think about that. On a scale where 0 is definitely natural and 10 is definitely alien tech, a 4 is, well, it's pretty significant. He's not saying it's a sure thing. He's saying that, yeah, it's probably natural, but the alternative is so plausible that we have a scientific duty to take it seriously. It's not about jumping to conclusions. It's about being open to following the data, no matter how strange it gets. And you know what? We might actually get to investigate it up close and sooner than you'd think. There's this really cool proposal floating around to use NASA's Juno spacecraft. It's already out there orbiting Jupiter. The idea is, with a few clever tweaks to its path, we could actually send it on an intercept course with 3i/Atlas for a flyby in March of 2026. Can you imagine the images we'd get? What an incredible opportunity. So when it's all said and done, does it really matter if it's a rock or a spaceship? Oh, absolutely. But here's the thing. No matter what it turns out to be, a comet or a probe, the discovery of 3i/Atlas is already a huge deal for science. Think about it. This thing is a messenger from the stars. It's a literal physical piece of another solar system delivered right to us. By studying it, we learn about how other solar systems are built. It also pushes our detection systems to their limits, which is great practice for finding things that could actually be dangerous. And maybe the biggest thing, it forces us to ask some really tough questions. Like, what would we actually do if we found undeniable proof of alien tech? It helps us figure out our place in, as Professor Loeb puts it, our cosmic block. First we had Oumuamua, then Borisov, and now this giant 3i Atlas. And our ability to scan the skies is getting better all the time. That means we're going to find more of these visitors, way more. And that leaves us with one final, pretty heavy question. As these mysterious travelers keep showing up at our door, are we really, truly ready for what the next one might have to show us?